This video is going to go down a rabbit hole inside of a rabbit hole and more capture this for my own selfish knowledge. But you might find it interesting to join me on this, to take you into a corner of Azure networking that you'll probably never arrive in, but if you do, you might find it useful. So remember from the previous video, and by the way, you'll have to go and watch the previous video on Azure NetApp Files, UDR considerations to get the baseline here. The previous video we talked about coming from on-prem over ExpressRoute, going through the gateway, going through a UDR to an Azure firewall, going to Azure NetApp Files volumes, and the considerations around UDR prefix length, matching ANF subnet prefix, and the difference between basic and standard and how they respected UDRs. Now let's bring in another technology here, ExpressRoute FastPath. So ExpressRoute FastPath, for those that are not aware, is something you can enable if you have the right SKU of gateway, so the more top level SKUs like Ultra and AZ3. You can enable it on a connection basis. And what happens is when you do this, let's now say this is FastPath enabled, traffic comes into the Microsoft Edge, and rather than the traffic going direct to the gateway and then to your endpoint, traffic will come into the Edge, bypass the gateway, and go to wherever it was you wanted it to go. Why would you want to do that? Well, bypassing this gateway has got performance benefits, slightly lower latency, saves about 0.5 milliseconds. Go and watch my previous video entirely around ExpressRoute FastPath and why you might want to use it. Don't have capacity restrictions that the gateway introduces. Don't have to worry about gateway scale, etc., etc. Once you're inside of that realm of using FastPath, so let's say we've entered that door, there's another deeper level of FastPath you can think about, and that's visible when you look at the document. So this is the ExpressRoute FastPath document. If you see here within the section on circuits, you see here there's a statement that says support for virtual network peering and UDR over FastPath is now generally available in all regions associated to ExpressRoute Direct. So again, this video is not going to talk about ExpressRoute Direct versus regular ExpressRoute. I've got another video, go back and watch that, all about ExpressRoute Direct. But ExpressRoute Direct essentially is when you connect your network to Microsoft with a back-to-back cable rather than working with a partner. So let's introduce that. Let's say this circuit now is an ER direct circuit, which it is in my updated lab. When you use the FastPath feature with the ExpressRoute Direct model, you get some additional features of FastPath. And that is this support for UDR and VNet peering. What does that mean? When you come in via the FastPath method, which is to bypass the gateway, you can use that to access things in peered VNets, as well as the hub or wherever the gateway exists. And also, you can get the FastPath technology to respect the UDRs you've got configured on the gateway subnet, right? So if you imagine in this diagram, we want all traffic before it goes to the spoke to go to Azure Firewall, and we have a UDR which makes that so. You need this UDR support with FastPath to get that feature working. So effectively, traffic comes in here, and before it goes to the spoke, you know you want to go to Azure Firewall. So the FastPath technology has to know, okay, don't send it direct to the spoke, send it because of UDR logic to my firewall. And that's what using FastPath with ExpressRoute Direct enables you to do. So I've enabled the ExpressRoute Direct, I've enabled my FastPath, I've got my gateway route there, and I just want to introduce an additional consideration when working with this topology and Azure NetApp Files and other things that use system routes that you kind of have to be aware of. In this diagram here, remember on our previous video on Azure NetApp Files, we said Azure NetApp Files leaks out a system route. So when traffic comes in without FastPath enabled into the gateway, you have to have a /28 inside of the gateway subnet to steer traffic to the Azure firewall, because the gateway's inside of the VNet, the gateway's in the SDN, and it gets the /28 route. So you have to have that /28 there. The nuance here is that when you enable the FastPath feature with ExpressRoute Direct and the UDR programming effectively gets moved down here, right? This becomes the decision maker, not the gateway. The gateway's not in the data path anymore. You don't need that /28 here, because this ExpressRoute circuit is not getting that /28 route that's leaking in. The ExpressRoute Direct circuit's in the edge network. It's not part of the system route learning process. It's not sat on the SDN. So what that means is, as we'll see, you can just have the /24 route and traffic will get taken to the firewall for NetApp files. And of course, you still need standard volumes. So if you're still with me, and I don't blame you if you're not, because this is pretty out there, we still have our UDR on our NetApp subnet pointing traffic back at Azure Firewall, so that's all good. Our gateway subnet UDR just has the /24, doesn't have a /28, so this gateway subnet UDR points traffic for the entire VNet range, not for the /28 NetApp range, which, as we said before, see the previous video, leaks out normally. If the ExpressRoute gateway with no FastPath was a decision maker, that UDR wouldn't work for NetApp. You'd need a more specific one. But because we've got FastPath, because we've got ExpressRoute Direct, that route programming is effectively moved down here, and that /24 will then take traffic to Azure Firewall. By the way, just as I'm down at this layer, it's interesting to note one thing that happens with this combination of technologies. If I show you the route table here of my ExpressRoute circuit that's running on ExpressRoute Direct with the UDR feature, notice how in the learnt routes I see 10.10/16, yep, that's my hub address space. I see some other bits and bobs which is not related to this demo. I do not see 10.168.2.0 in the list. And the reason for that is, when I enabled FastPath, this UDR kind of supersedes that BGP route effectively. It says, you know, don't send traffic to these IPs, the 10.10 ranges, that's my gateway. Go see the video 2 or 3 videos ago about BGP and Azure gateways to understand that. This static route kind of gets plumbed into ExpressRoute Direct circuit to take traffic straight to the Azure firewall. So that's an interesting quirk there when you enable this feature. Anyway, let's make sure all of what I just said actually makes sense when we test it. So this config without the FastPath feature on ExpressRoute Direct wouldn't work here. It wouldn't be sending traffic to the firewall. But we can verify that. So if I try and mount that standard volume again, so the .165 address, mount it to, let's say, the O drive. See, that works straight away. And what I'm expecting to see now is that traffic, when it came in and went direct to the firewall, despite only having a /24, I'm now going to go and check the firewall logs to make sure I saw a piece of traffic sourced from here to here. And after giving a few minutes for those logs to ingest into log analytics, I run my query here and we can indeed see traffic coming from here, from my client on-prem to ANF volume on all the ports we associate with NFS traffic. Okay, I'll try and give a summary of this video. But in short, with ExpressRoute Direct, we have this ability to use FastPath in a way that lets us honor UDRs on gateway subnets and work with peered VNet resources. And that can have some considerations. When those UDRs get pushed down to the circuit, they effectively steer traffic to the firewall, irrespective of system routes being learnt by the gateway under the covers. And this can affect features such as Azure NetApp files that have unique attributes when it comes to system routes. Like, none of what I just talked about would affect virtual machines, because virtual machines don't leak out system routes. They are captured by the system route of the CIDR range of the VNet, which is covered by the UDR you would probably already have on the gateway subnet. Some other things that could be caught by this, I mean, start thinking about private endpoints. Are you using network policies on the subnets or /32 interface endpoint routes leaking out? See the video on private endpoint traffic inspection in the past. So again, this is a nuance and a nuance, but if you're deep in the Azure networking rabbit hole, maybe you found this interesting. Thanks a lot for watching.